Hi everybody, this is Kaveh here, and this is my implementation of Ben Eder's 8-bit computer on PCB. So, like many other people, I started this project on breadboard about early 2020, and essentially I built every module following Ben's videos and started testing them and so on. By the end of the project, when I actually reached the control logic, I got a bunch of issues in regard to the power and of course all the crazy wiring that comes at that section. So at this point I actually decided to convert the project to a PCB version, and essentially the idea was to I liked the project so much that I really wanted to keep it, and probably the best way to do it was just to build it on PCB, and this way you could build a project and keep it as a, I don't know, an educational piece, or maybe as a discussion piece. So I decided actually using some of the schematics that was previously posted by Ben himself as part of the documentation. However, the original documentation was just a single PCB design, meaning that everything was sitting on a single PCB, and you're basically just soldering the parts to it. But I really didn't want to have the whole thing as a single PCB, because the end results for this project is not so exciting. Essentially, the exciting part is really being able to build each module and test it and understand it and learn from it. And therefore, I still believe building it on breadboard is a great idea. And if someone really wants to start that project, I highly recommend to actually do it on breadboard initially, and follow the videos and understand everything. But I don't know. If you're like me and you want to keep the project for a long time, probably breadboards will not be the way to go, because all the wiring and connections probably get loose over time, and you probably be spending a lot of time troubleshooting the wiring and connections. So anyways, however, as I said, the PCB version and the original documentation was just a single board, right? But I didn't want to go that route. I really wanted something that is be as close as possible to the breadboard version, meaning that something that is modular, something that you could actually build each module following Ben videos, and then kind of test it, understand it, and then kind of interconnect those modules together to build the whole system. So with that idea in mind, I started basically learning, EasyEDA, as the PCB design software. I actually tried KiCad and KiCad, or some other options that are out there, but I guess EasyEDA was just, I don't know, easier for me to pick up, and I used it, and I started module by module, essentially following Ben videos, and also, as I said, some documentation that we have. And then I came up with a modular design. I said, okay, what if we could actually, make each part of the build, including, let's say program counter or registers or ALUs, as a single PCB, and then somehow connect that to a bus. This way, you'll be very close to the original build in regard to this, the location of the modules, and essentially the role of each modules, and so on. So therefore, this is the final results. Actually, I built this again early 2020, about a year and a half ago, but I really didn't have time to take a video and basically post it so that other fellows could see it. The point is that there has been a lot of people actually trying to do it in modular way, and I haven't seen that much, at least on the web. So I decided today, hey, let's post a video and see if it would be interesting to some people. Anyway, so the design is again quite similar to the original version on PCB, meaning that you gotta get the same module essentially. You gotta build a program counter, the A and B register, the ALU, the output display, and then that little control module for the output, and then of course the LEDs for the control logic signal. And then you have the clock module here at the top, and then you have memory address register, RAM, the memory data input module that you manually program the RAMs, and then instruction registers, and then finally the control logic. I even try to actually keep the locations of the chips very similar, as close as possible to the original build on PCB. And here was the idea, right? So I said, okay, if I design it this way and kind of follow the same layout and stuff, if I really wanted to build it on PCB, I could still watch the videos, and basically just place the chips rather than wiring those on breadboard. I could just simply solder the parts to the PCB and place the chips, and then start testing the module. So that was the idea, and I guess it turned out pretty good. Now, in general, I had a couple of issues actually after building it on PCB, and some of those issues were my own mistakes, meaning that okay, I had some issues in the routing of some of those connections. But also I had some issues that looked like to be actually other people's issues. So there are some signals in the original build that are kind of left floating on this board, and that's mostly probably, and we have some and or NOR gates here and there. And normally in a good build, especially when you're building on PCB, you want to basically either pull down or pull up those with a resistor. However, I didn't actually do it on this build, and the reason is that I just wanted, quickly convert the original design to PCB board, and I also didn't have too much experience. I'm not an electronic engineer or something like that. It's just a hobby for me. I'm actually a network engineer, computer engineer. So this was just like, a learning process for me, learning the software, learning how to build PCBs. In old days I used to build PCBs, but it was just all manual process of drawing line by line and a piece of PCB, and then using assets and stuff to make it. But these days it's a whole different story. You basically use software to design it and send it out to China and get these super nice PCBs at a reasonable price. Anyhow, so yeah, again, as I said, and after building it, there was a couple of issues, and then I went through them one by one. Initially, I didn't have a scope, but and then I got a scope, and I started actually learning a lot and finding and tracing, signals here and there. And then I basically troubleshooted a lot of stuff, except the small issue, which still exists, and it's actually random. That's why I couldn't find it and find the root cause of it. So I sometimes get a memory overwrite on my memory module, and it's kind of random. I wasn't able to figure out what actually triggers that. So that's normally happens when I switch between manual and auto in my clock, or sometimes maybe when I actually start to change from manual programming to auto run on the memory. Anyhow, I know that there has been some discussion about it online, and some people actually recommended pulling down the RAM write signal, or excuse me, pulling that RAM write signal up, or even here we have the programming key that they recommended actually pulling it down. So I actually done those, but still I have that issue. But that issue seems to be completely random, and most of the times, and don't see it, but sometimes I see it. So I'm just assuming that should be probably, I don't know, a signal coming in, affecting another signal. Anyways, other than that, everything is actually working perfectly fine. And as you can see right now, it's actually running the, Fibonacci program, and it's running smoothly, no issue. But again, when I play with this, programming keys, I get some memory corruption from time to time. So I basically run every program that are, in the original videos, and then of course I came up with some of my own programs, multiplication and so on, and then I kind of implemented those. But then again, that was an amazing project. You're gonna learn a lot, and the fundamentals of, computers and how each module works and so on. And it's really a fun project. Thanks to Ben Eder for all the work actually he put into this project, and helping everybody else, understand these concepts. Really, I can't, appreciate enough of what he has done for everybody. So, but at the end of the day, when you build this eventually, and go through these steps and kind of learn how everything is interconnected or works, you kind of reach a point that you want to actually expand the system, right? You want to, for example, expand the memory, or you want to have a bigger program counter, or so on, or even maybe changing the display. These are some of the ideas that came to me, and I started actually designing little, new circuits and adding it to this one, and basically, and those are all great, but I thought maybe that's going to be a whole new project by itself. If I really want to expand on it, maybe I could. This project as is, in itself, it's really a beautiful, complete project, and maybe I come up with a new design for a new project. So that's why I could just modify, and especially with this design, it's modular, and I'm going to show you what I mean by modularity. But at the end of the day, I really wanted something to be more capable. So we're going to talk about that at the end of the video. I'm actually looking at some new projects, but for now, let's have a look at this build. So this build is all modular. As I said, it has a total of 14 modules, very similar, very close to the original design. And then we have a bus. So bus is by itself, it's a PCB, and then everything else is as a module that could be plugged into the bus. So let's have a look right now. I'm going to turn it off, and essentially, oh, by the way, there has been, little modifications here and there. For example, on the clock module, I have an on and off button, and I have also, let's say, USB port there. It's just make the build cleaner, and I see that I have also an LED, which is showing, the whole power for the whole system. So a little modification here and there, but in general, majority of the modules, everything is kind of exactly the same, except that, as I said, during build, you see that there are some issues here and there, and I actually read about those online, and I try to, overcome those issues, which some of them has been taken care of. So now let's turn the system off and show you how it has been designed. So system has been designed, as I said, on a bus, and bus is basically a long, PCB board that everybody kind of connects to it. And then the bus has, of course, I use some spacing, those, plastic, what do you call it, risers, and basically that sits on these, bases, and then everything else will be kind of connected to that bus. Now every module here has basically two sets of header pins, right? And that's done on purpose. So yeah, as you can see, for example, this is the instruction register module, and just like the original one, you have the 74LS245, which was connecting us basically as a register, as a buffer to the bus, and then you have the 74LS173s essentially. This module has two sets of let's say header pins, right? One at the back and one at the front, right? The ones at the back and the one at the front are identical. So essentially they are connected pin by pin. However, the one at the back will be connecting the module, you know, to the bus through a female socket, which I have it on the bus, right? So it's just going to slide in on the bus and connect this module. However, I also have all the header pins in front, so that you could have actually access to every signal that is coming in or going out of a specific module. And those header pins and signals depends on the module, right? For example, here we're looking at the instruction register. So instruction register, we have, you know, bus connections. We have some instruction register data that are coming from this module to the control logic. We have instruction register in, instruction register out. Hopefully you guys can see it if my camera, you know, cooperate focusing. And then there are some, you know, pins that are not connected to anywhere, but I also have, you know, VCC, ground, and clock on this module. So essentially the power for this whole system is actually coming from the clock module. I connected, you know, the USB and of course the power rail, and then it comes into the bus and then it will be distributed to every module in the build. However, each module has its own, you know, connections to the bus, so it could be fed through, you know, that you know, 5 volt and ground. And this specific module, we also needed a clock, so clock is also coming from the bus to here. So that's really about it, and that's how it has been built, and it's quite clean and nice. And still, you keep, you know, the modularity of the original build. You could just build this unit and test it, because now you could, you know, use the let's say these pins to power it up, and then you could use the bus lines that you have it just connected to a piece of breadboard with some LEDs and test it. And essentially that's the same thing for every other module. Let's say, I don't know, let's say look at the you know, memory address register. So memory address register, for example, has its own signals, right? We have VCC, ground, clock, memory in, prog, and then clear, and then some bus, and then of course some address, right? So you could use those lines to address it, and the bus is obviously connected to the bus lines. Now the point is that each module, again, as I said, has a pin for every single signal that is coming in or going out of that specific card. That enables you to, you know, test it, or if you want it, you could use those signals to I don't know, measure something, or you want to expand it, you could actually tap into those signals, and so on. Also, you see that the bus is a little bit wide, and actually that's has been designed on this way on purpose, so that I could slide in, let's say, a piece of, you know, breadboard in there, and I could build something here and use the signals and test it and so on. So yeah, that's really all about the build. I've been enjoying the build because I'm not worried anymore about, you know, wiring issues and so on, and it's really a piece that I could keep. And again, as I said, I've designed in a way that could actually keep it in a long term. Maybe I don't know, I could install the whole thing on a, you know, a piece of plexiglass using, because these, you know, risers here, they could actually be screwed down, let's say to a board or a plexiglass and so on, because I have, you know, everything is kind of have this risers at the bottom. Also, you know, each modules also, you know, have you know, some plastic spacers, or what they call it, risers on the other side, so that it will be supporting actually when the module sits on the bus itself. Yeah, that's really all about this build. I know you know, some people has been actually trying to do it a modular way, and I replied to the comments, and I promised I'm gonna post a video, and I guess today's the day that I'm posting video. Hopefully you guys will be able to get an idea. And even for the, you know, for example, the EEPROM programmer, you know, we had an EEPROM programmer thing that we were building it during the project. I also have a PCB for that. You just, you know, put the EEPROMs here, and then, you know, you have a Raspberry Pi, again, modular. Excuse me, I said Raspberry Pi, good gracious. An Arduino Nano here, that is modular. You could just plug it in and essentially just you know, use it for programming your EEPROMs, right? So that's the build. And yeah, I mean, some of you may probably ask that if I have the you know, design files for EasyEDA and then essentially the Gerber files and so on. I do actually have all the files. The only problem is that when I actually designed it about, again, as I said, a year and a half ago, I had a, you know, base design. I sent it. I was excited to, you know, convert it to PCB, and then I actually received the PCBs. But after receiving the PCBs and I kind of built the whole thing and started testing it, I found some improvements or some issues here and there. So I started actually just doing it on the existing one. I didn't reorder or I didn't revise the original you know, design file. So meaning that the files that I have currently may have some you know, issues here and there that I didn't actually have a chance to go back and fix them. Meaning that if you actually send those files for a PCB build, you may actually have some issues. That's why I'm not sharing those files at this point until I have a chance to go back and actually you know, modify them and make them the final version of each file. I know that a couple of modules have some issues. Hopefully, you know, one day I have time to go back and revise everything and post all the files. And that's really about it. It was just you know, short video to show you what I have done and how I approached the modular design, and hopefully that you know, inspire some people, give idea to some people to do their own design. All right, so the next project is actually a very exciting one. I'm still thinking and kind of working on it. That one is also an 8-bit computer. It's kind of an expanded version of this build, right? And that one actually done by someone with the handle of SLU4, or maybe SLU4. Hopefully, I'm pronouncing it right, on YouTube. And if you look at his design and watch his videos, it's an amazing build. However, it's not as detailed. I mean, at least the videos are not as detailed as Ben Eder's videos. He goes through multiple sections of the build, but the design is very good. And essentially, as I said, I was actually trying to come up my own design, and then I watched his videos. And when I was doing research, I saw them and I watched those videos, and I got really excited about building it. And I think that system also has a lot of potential, since you with that one you could actually have I/O, input output. You could make a terminal connection to the system rather than, you know, manually programming those. You could actually terminal to it and, you know, program it, let's say from a computer, right, using a keyboard. So that's amazing. Also, the display is also completely you know, going back to your monitor, essentially the data that is generated, or you know, the terminal is basically the way that you interact with the system, and that's pretty cool. So yeah, again, he has done it on a single PCB. I'm thinking actually to do it on in a modular way, but again, let's see how it goes. I'm pretty sure that also requires a lot of time to build it in a modular fashion and then test every module and so on. So hopefully I have time to do it, but let's see how it goes. All right, guys, hope you guys liked it and have fun. Catch up with you later.